First Sergeant Kemp here with Company D, 2nd United States Sharpshooters, and today in the workshop I'm going to show you how to build this field-made Civil War officer's desk. For complete cut lists and instructions, be sure to pick up A.J. Hamler's Civil War Woodworking Volume 1. The carcass of the desk is a repurposed Civil War hardtack box. So if you need to figure out how to make one of those, we have a video on that. It should be up here somewhere. And the other thing too is if you're gonna want to put like big notebooks in here, you may need to stray away from the standard hardtack box dimensions and maybe use more of a complete 1x12 for the carcass construction, so you can get that depth that you might need for your materials. This again starts with a frame and panel construction door, and it is a hardtack box lid. It has some dividers, it has a nice drawer, and a modular shelving unit with hand-cut dados that I'll show you how to make later. This is more of a millwork project than it is a woodworking project. You are going to spend probably more time on the table saw and at the thickness planer than you are actually assembling this piece. Now, the internals are mostly 1/2 inch, the drawers 1/2 inch and 1/8 inch for the bottom, the tops 5/8. Hamler lists all of that in his book. Now, if you don't have the ability to thickness your wood, which a lot of people don't, you can use straight 3/4 inch throughout. That would make sense if a soldier making this had limited time and limited tools. He would just break up more hardtack boxes and design it, and you would just change your measurements for the internal components the way that you want. The other thing you can do is at the box stores they have essentially like hobby boards, like 3-foot pieces of wood that are of different thickness, and you can buy those. It's going to cost you more, but you can buy a bunch of those and just glue up panels, and you make a narrow board, a wider board, and you can have the sort of the thickness variety that you see here. This is a unique piece. It's a mix of, I guess, sort of civilian hardware, like a half mortise lock that a soldier would scavenge, as well as the hinges. And I also ordered some blacksmith handles off of Etsy because blacksmithing was a lot more common then, and I like to support independent makers. Now, camp furniture should reflect as much of an impression as the rest of your uniform. These pieces should tell a story. Now, during the Civil War, it was a volunteer army on both sides. Everyone came to the war with a day job. And if you look at your company's enlistment papers, you can actually see a wide variety of occupations that soldiers brought with them into their military service. So when an army was stationary, whether winter quarters or was just parked somewhere, those armies would generally be by a farm, a town, or a city. And they had access to civilian tools and civilian workspaces and materials, as well as the thousands of tradesmen that supported both armies. And we kind of cover that in our Civil War carpentry tools video. So it's not like soldiers had no access to be able to do this. Soldiers were also able to get passes. It wasn't very difficult. There were times during the war where it was more difficult than others, but soldiers could easily visit another company or a regiment or go into town as long as they had permission from their commanding officer. So they could get away and build this. They weren't making this in the dirt and mud of their dog tent. They were doing this, odds are, at a workbench. And the way that it's designed, the materials that are used, the fine finish or lack thereof is going to reflect the occupation, skill, time, and resourcefulness of the soldier building it. So keep that in mind. There's a lot of leeway. So if you're, like in my case, so I portray a jointer, and Company D actually did have a jointer. His name was James Pendleton. And we know that for a fact. So it makes perfect sense that the jointer in the company would make a slightly nicer finished piece. There would be some hand-cut joints somewhere in here. But if you were just a carpenter, you could just glue and nail this whole thing together and it would still fit that story. So do your research. Soldiers had day jobs, and when they got bored, they wanted to, put themselves to work. So we are going to quit talking and go ahead and get starting cutting some boards and building this thing. If you have the book and you're following along, Hamler starts with building the center console of the desk first. And what I'm going to do, since I'm doing something slightly different, is I'm going to start with the shelving unit first. Now, all the internal components that we're working with right now are going to be 1/2 inch thick. And so I'm a joiner. That's the impression that I portray in our unit. And a joiner means you cut joints. Now, Hamler's work uses cut brad nails, which you can get from Tremont Nail Company. Not a sponsor, but they're really affordable, shipping's reasonable, good quality products, and they have a huge selection, everything you need. I don't have any brads, but I'm going to use some really nice fine finish nails. And so everything is nailed together. But since I'm a joiner, and this is sort of a special gift, I wanted to do some basic joinery. And so for the shelving unit, what Hamler does is, again, he's using a lot of wood. So these writing desks in his book are super heavy. So he has this sort of like modular shelving unit in his book. But instead of having a dado, he just uses smaller pieces of wood to kind of act as upright dividers. And that works. It may be really accessible to most people, and I think that's why Hamler did it. But I'm a joiner, and I want to have the versatility and save some lumber costs and some milling time. Like I said, already in this a lot of time for milling. But the nice thing about cutting dados into a piece is that you can still make it modular. So if you need a taller shelf, you can just pull a shelf out and put it somewhere else. And since these aren't going to be secured into the box, you can actually remove the whole shelving unit completely from the desk and have more large upright storage if you need it. And the other thing too, the reason why I wanted to do this, you can do this all on a table saw or with a router, but I wanted to get some hand tool work into this project because that is what really sets it off. I'm going to show you how I hand cut these dados. Handwork actually goes pretty quick, so don't be afraid of it. For our friends in the UK, it's called a housing joint. So I already did one, and now I'm going to show you how I set up the other one. So Hamler has these set up. Gotta make sure, always mark your pieces. And this is my face side. So Hamler has these set up so the shelves are about 3.5 inches tall. So what I do is I come in with my square and I'll mark 3.5 inches up, and this is my baseline. And then I'll use my square and I'll establish a knife wall with a marking knife. And these things are super critical in hand tool work. And then I'm going to do the same from the top. And I'm going to establish my top baseline. Now, and then I'll do a knife wall again. And you can see here, hopefully it'll focus, I label. So since this is the top, the dado waist is going to be below my baseline. On the bottom, the dado waist is going to be above the waistline. So it's important to mark that so you don't cut the wrong side. So what I do next is, here's the other trick for accuracy, is now you have a knife line, you have something to register your piece in. Right here, we have our baseline. So because we have a knife wall, we can put our marking knife in this. So you register your marking knife, you push the board against it, and then you mark to the thickness of the board itself. And then you make a mark, and then you do that for the other side, and you make a mark, registering off this. Now, if you can hold it steady and the board's pretty flat, you can just scratch your knife line all the way in, gently at first, and then a little bit harder. And then you get your second knife wall. And this will be exactly matched to this particular board. And you can see that I label my shelves. Now, if you're making this to super tight tolerances, this part's really important. I'm actually cutting these a little oversized so that they're going to be a little more interchangeable, and they'll accommodate more expansion from humidity. So that way they won't get crammed in there and you couldn't actually take it out when it's in the field. You have to get it back home and let it dry out again before you can move the shelves around. So I do that for the first and the top one. Now, then I have 2 lines established. And then if the height of the box is any way different, say it's cupped or bowed in the middle of the board, this board may not fit Hamler's blueprint idea. So what I do is I just find the center and I figure out where 3.5 inches works on both sides, thereabouts. But visually, it just has to look to the eye as being center. Then I'll strike my baseline, then I'll take my other board, and I'll do the same thing. Now, typically when you cut joints, you work in the rule of thirds, but I wanted to kind of show off these housing joints. So you can use, like we talked about in our carpenter tool video, you can set a marking gauge, got a little scratcher right here, and you can mark your depth. But what I do, and this is something I learned from watching Paul Sellers, is I'll just use my router plane, because I'm going to use this router plane, the Stanley 71.5, to clean out or finish up the dados. And so I'll actually set my router plane iron to the depth that I want, and I'll actually use that to mark my depth. And then if I have to reset my iron, then I have a reference point to reset it to get to the final depth. The other nice thing about using a router plane is that you can be much more accurate where you mark your baseline to. So once I have the layout done, I'll mark the baseline of all of my dados, and now I'm ready to start chopping. Now, if you're new to traditional woodworking, these knife walls are sacred, okay? Don't compress them, don't scratch them, don't pry against them. This is how you get nice crisp edges on your pieces. So we need to clear out some of the waste first gently. And to do that, we'll just take a wide chisel, make sure all your tools are nice and sharp, secure it in the piece, and then all we're going to do is just take kind of a skim cut and just cut a little bit of a relief on these knife walls. So I have my knife wall, and I'm just going to push my chisel in until I hit that knife wall. And you'll feel a positive stop, and you just go all the way down. And we're going to do most of this clean out with just a chisel. And once you get the hang of it, you'll be able to go pretty quick. And then you just flick out the waste. And this isn't going to be very much, but once we get through this step, then we can start using a chisel and a mallet. We go through this step because this knife wall is always going to give our chisel something to reference against, and that's very important. And then I also change position. You can do this all standing up, but accurate square chiseling, really, just like hand sawing, is about body position. So the reason I sit down and I sit in front of it is so I can back this chisel straight into that knife wall that we cleaned out, and I can sight down. And from here, I can see if my chisel is square or not. And when it's nice and square, I'll take my mallet and I'll give it a tap. And then I'll go down a little bit more, back into that knife wall, check for square, tap. Now don't make the mistake that you're gonna do this all in like one round with the mallet. A chisel will stop. It has a natural sort of built-in depth stop with its design. A chisel will only go in so far before you just start breaking pieces. So you don't need to beat the dickens out of it, because also on this first pass with actually hammering, if you hit too hard, you're going to push this knife wall back, and that's going to make your dado too wide, or it's going to make it sloppy. Either way, it's not going to be very good. So the first couple passes like this, just take your time. One pass, find the knife wall, check for square, and whack. And you do that. I like to do this all in one go. So I'll go and chisel in all these knife walls, and then I'll go back, and then just like that first move that we did, I'll go in with just hand pressure, and push into that knife wall. Now what you're going for, let's see if I can get this in, and that way we don't have to do this together in real time and have like a 4-hour video, is what you're going to be doing with the chisel is you're going to be essentially cutting a point in the middle. It's not going to be that true, sometimes it'll be pretty flat. But you're cutting down essentially to your baseline right here. And then once you get all this waste done, then you can go in with the router plane. Now you can see that I think I took about 4 passes with the chisel and clearing out my dados. I have these little peaks. Now if you want, you can go back in with a smaller chisel and clear out the tops of these things, but what I like to do is just go ahead and get started on the router plane and make a few extra light passes. Now, the other thing too is to keep in mind like reasonable expectations. This is pine. I don't want you to try to compare your joinery in pine to something that's done in a nice hard cherry, for example. I mean, just look at this grain. The grain's all over the place. So you have tight grain here, which should cut better. And then you have this really huge, this really wide, spongy grain. And what pine likes to do, even with super sharp, high-end tools, is that it'll want to compress and tear out. So this groove, depending on your board, may not look the prettiest, but as long as it's equally flat across its width, and your walls are straight and your knife walls are crisp, it's going to look really nice when the shelves are in it. So cabinet makers, joiners back then didn't really care so much what people didn't see as much as they cared about what people did see. So we're going to take light passes and work on cutting these peaks down until we hit our final depth. So let me get this back in here. You don't want to go all the way through your piece with a router plane, because what's going to happen is you're going to blow out this side. So you kind of work your way to the middle, and then you come back and you work towards the middle. Yeah, so here's a good example of the quality of pine that you work with. So on the tight grain side here, I actually got a nice shaving curl, right? On the wide grain, I just got a lot of compression and tear out. It's still going to work. The drawers are going to fit, and the outsides are still going to look nice because I took care of my knife walls. But don't freak out. This is sort of the wood doing its thing. So these are 8.5 inches deep, and whatever height is required. So see that fit? That's complete friction. That's not going anywhere. What I do to get that perfect fit is I'll use a smoothing plane. Here's like a little number 2 that works good. End grain's pretty easy to plane by hand. You just got to make sure your irons are freshly sharpened. The other thing you can do to fine tune your height to that perfect fit, because like I said, you might need a hollow. I mean, this board could be bowed severely in the middle. You can just glue a piece of sandpaper to a stick of wood, and then you can use that to take a few thou off your shelves at a time. So then I find my other face side. Just like that. And then I start lining up my shelves for the final fit. Number 3 is my top one. Like I said, I deliberately cut these dados a little too big, so everything's going to be fine. If it gets rained on, it'll still be able to function. But if this is just going to be in the house or like a display piece, you could probably make these a lot tighter. And number 1, face side. Now we are at the point where we're going to start our center module. Now the top of the center module is just a series of dividers. Now you want to kind of find where they're all in the center. So in my case, these are just over 2¼ inches in from either side. Then I mark that on the board, and I kind of go all the way around. So on the back, I'll put more reference lines so I can find centers and drill some pilot holes for the cut nails. Then Hamler uses wood glue, which would have been much more period correct than what I'm about to share with you. So I have these in place. I have them traced out, kind of like I laid out the dados before. So I know where these are supposed to fit. I have all my reference lines. But to speed up the process, I highly recommend every maker out there have something like 2P10. It's just a really awesome cyanoacrylate glue, and this one is sort of the thicker stuff, and it comes with an accelerant. So once you have your reference line, you put some of the CA glue on the wood, on the face side, and then I'll spray some activator on the end grain, and what the activator does is it turns CA glue into instant bond, which means this is already clamped after just a few seconds of application, and this way it's not going to move as I nail it together. Now I've put the sides up to our center divider. This is sitting upside down right now, and I wanted to show you this is going to be a good way to help you lay out the glue up lines and the nail locations for your center divider, because this is upside down. So this divider, the tops of these dividers are going to reference the inside top of the officer's desk. So you want to make sure that when you run your reference lines, that you're doing it on a flat surface. So if you have a good flat workbench, you can do it on there, or the top of a table saw would also be a really nice flat surface to operate from. So I laid these out earlier, and I'm just confirming that my lines are exactly where I want them to be. So what I'm going to do is I'm going to take my board, which I've already laid out for my drill holes. I'm going to drill some more pilot holes. This section here is going to be a drawer, but you can modify this however you want. You could have the whole middle section drawers. You could have like a really big drawer. You could have a couple smaller ones, or you could just have shelves. So how big you want the drawer, if you want a drawer, is going to be up to you. So again, I laid everything out where I want it to be. Make sure all my face sides are facing the right way. And this should just fit in snugly. So we don't need to use any CA glue to hold everything into place. You just got to line everything up on your layout lines and then nail it into place. Now we have our center divider assembled, all nailed. Now we just slide it into place. Make sure everything's nice and snug. And now we are ready for our tall dividers. Now, the other thing you'll need to do is, again, you'll need to nail the center module into place. And for that, you just find the centers of your boards, draw some reference lines on the top, all the way around, and drive some nails in so this stays firmly in place. And make sure that you check for square as you go. Now I have the two boards that are going to make up our dividers. So the idea with these dividers is that they stand up and hold papers and notebooks upright. So we got to figure out a way to cut some sort of decorative notch in here so it's easier to reach in and grab the papers. Some of the originals, like the sort of like the cabinet shop made officer's desks, would have really elaborate profiles drawn out. That's something you can totally do and give you some extra time to get handy with a pair of dividers. But for this one, I want to keep it fairly simple and just do sort of a nice half moon shape. So what I do is I kind of figure out how much I want to come down from the top on each end. And so for this, I have about 1.5 inches. And then I figure out how deep I want the cutout to be. Then, since this circle, this imaginary circle that I'm making, sticks out further than the first board. I put the other board next to it, and I just kind of start moving stuff around and seeing what I like. And this way you get a symmetrical shape. So I'm thinking I like this that I have so far. So I have my reference point, got everything firmly down, and I'm going to scratch. Just like that. And let me darken this in a little bit so you can see it better. Green wants to walk my pencil all over the place. There we go. Coming around. Gosh. There we go. So now we have a pattern, something like this. A nice half moon. It's nice, basic, and simple. And so what I'll do now is I'm going to make sure I have the right sides of these boards together. I'm going to double stick tape them together, and then I'm going to run them through my bandsaw. You can see we got our dividers cut out on the bandsaw. As you can see, I couldn't find my double stick tape, so I just cut them individually. I cleaned one up on the bandsaw, then the spindle sander, then I used that to trace my pattern onto the second one, doing the same. The spindle sander really helps to even out any inconsistencies in the cut and also remove any tool marks left from the bandsaw. Now, you may be asking, hey, First Sergeant, what happens if I don't have a bandsaw? No big deal. You can use a jigsaw. Those are pretty affordable, and you can find them at yard sales. You may even already have one. If you want to stick with old-timey tools, you can just use a coping saw. It goes pretty quick, especially in half-inch. Or you can use what they call a turning saw, which is just a big frame coping saw. These are really handy. I mostly use them on big stuff, but you can use them on this. And you may be asking, well, what happens if I don't have a spindle sander to smooth out my radius? Well, no big deal. You can also use a spoke shave, making sure that you shave into the curve, flipping the piece back and forth. That'll give you a nice, really smooth surface. The other thing you can do if you don't have a spoke shave is to save your cutout and wrap some sandpaper on it. And then you can sand by hand inside the radius and get a nice, smooth, consistent result. The biggest thing, you don't want any visible tool marks, and you want it kind of smooth because this radius is designed for the hand to go, in. You don't want it to catch or hang. Then you have to figure out your spacing, where is this going to sit so it's even. And that's why I like to build this side over, because if I'm off at all, then I can split the difference here really easily. Just so happens everything came out pretty nice. So each of these dividers, each space is pretty much dead on 2 inches. So I just went to the table saw and ripped some scrap to 2 inches wide, and I cut a couple of pieces so I can use these as a spacer to help me line everything up and keep it nice and square while I draw my reference lines so I can nail these dividers in from the top and the bottom. Now we're ready to make the drawer for our field desk. And in Hamler's plans, he's using 1/2 inch for the carcass of the drawer and 1/8 inch wood for the drawer bottom. But I wanted to put some really nice visual interest and make this really stand out. So for my drawer, I'm using some maple with some figure from a knot in it that I normally wouldn't use for projects, but when you're trying to do like a showcase and add some visual interest, these are really great for those sorts of uses. They make really, really nice drawer fronts or cutting boards, for example. And for this, I just started with a rough sawn 3/4 inch walnut board. I cut to rough dimensions, and then I cut it to thickness on the bandsaw. And so the front and the back of the drawer will be walnut with the figure facing out on the front and facing in on the back. For the drawer sides, I'm using hard maple. Then again, I cut on the bandsaw to thickness and ran through the thickness planer to clean it up. And for the bottom, I did the same thing with cutting 1/8" boards for the drawer bottom. Now, you can, if you're using a bandsaw or if you're being awesome and ripping these by hand, you can leave one side of these drawer bottom boards rough sawn. It was a common practice for traditional woodworkers in the day to only surface the finished side of the drawer bottom, the part that you see and you put your items on, and the bottom side would be rough sawn. So it'd be fitting and save you some time to leave these rough. Now, if you, for whatever reason, can't get 1/8" thick boards, don't stress. If it really comes down to it and all you can get is some like 1/8" plywood from a craft store, this is probably the place you can get away with it. It's not historically accurate, but once the plywood is set in the grooves, you can't really tell without really investigating that it is plywood, and it's a drawer. So, you know, unless it's upside down, laying out, or pulled apart on a table, people are never going to see that it's plywood. So that's a place that, if that's going to keep you from making a nice drawer, that's a place you might be able to compromise reasonably. Now, for putting it all together, we need to have some grooves along all 4 sides of the box. And you need to cut your grooves about half the depth of your side pieces. And I'm going to cut my grooves 1/8 inch from the bottom of the drawer sides. My bottom pieces are a little thicker than 1/8 inch, so I'll make an initial pass running all my boards together at the same time to the table saw, and then I'll move my fence just a little bit each time to sneak up so I can get that nice perfect fit. Your drawer bottoms, you don't want to fit tightly. You want to have a little bit of wiggle in there, because these are going to expand and contract, and you don't want to blow your drawer apart, because you know the wood's going to swell and it's going to blow out your glue joints on the drawer face and the drawer back. And then we'll custom fit the drawer bottoms once the carcass of the drawer is assembled. Once we have that done, we're going to cut some rabbets into the front and back of the drawer. And your rabbets, again, are going to be half the thickness of the face and backboard, and whatever thickness your side pieces are. So these aren't exact dimensions of anything, so I just always cut my pieces to work with each other. And so you just cut that rabbet the depth of your sideboards, and then we'll glue everything together. Well, our drawer is complete. We have our grooves all along the bottom, and you can see how when you cut the back off, you can just slide the panels in. Depending on the fit, you can drill like an oversized hole in the back panel here, and then run like a tack or a nail or something. So that way, if this expands and contracts a lot, it'll be able to wiggle, but it won't be able to just fall out the back. Most of the time, just a nice snug fit in the grooves is all I use. I haven't had too much of a problem with it. And then I drilled a 7/8 inch hole in the center of the drawer face, and just for a little bit of style in contrast, once this gets finished, I drove some 1/8 inch dowels into the corners of the front and the back, and it will add quite a bit of structural integrity to the piece, but I just do it because it's a nice piece of contrast. So with this done, it's time to work on the door. So we're on the home stretch. The door is a frame and panel construction, which means you have 4 pieces that will make a door, and I have one more side to do for the top rail. And then you just groove the inside of all of your pieces so that you can accept your panel. Now, for my panel, I am using my hardtack box lid. And I'm gonna cut this down to fit inside those grooves, and then I'm going to thickness it down to 1/4 inch so this slides in, and it clearly looks like it's a repurposed hardtack box. If you're looking for a cleaner look to your piece, you can skip the stenciling and just use wood. Wood choice is kind of important for this. You can see here that I have all rift or quarter sawn pine, and that it looks great because it's clear. You're not going to have, there's no knots in this. It's going to be really stable, and even sort of like the junky boards are going to have good wood on them. So here's an example. So this is what I did. I took a wide board, and box store wood is almost always going to be flat sawn. But on the edges, see where this grain runs straight? This right here is decent rift sawn wood, and you're going to get nice straight grain, and it's going to be really stable. And then this middle cathedral stuff, that's just the core of the tree. This is just junk. This is firewood. And then you usually have a little bit more on the other side. So it makes for a much more professional piece, because when you have something matching like that, that tells someone that this person not only knew how to build, but also knew the importance of wood choice for specific components of the piece. So keep that in mind. The grooves on this piece, you can just use a table saw or a router. I use my tongue and groove plane because it's really fast. And then for the little tenons here, I just cut these by hand with a tenon saw. Now with the grooves cut and all my face sides marked, I'm going to use my marking gauge, and I'm going to use the tenon pins on here to lay out my cut lines. So make sure I have the right side right here. And then I'm going to mark my cut lines, always from the face side, because if you have any inconsistencies in your boards, it's all going to be on one side and not the side that you see. Lower it in your vise, put it on a nice angle, and with your tenon saw, cut down to my baseline on the back first, making sure that my cut is perpendicular, and then I'll work forward following my tenon lines. Just don't overcut your lines. Okay, now we're ready to cut the shoulder. Now you can cut the shoulder first or the tenon first. It's kind of a personal preference. So, get this out of my way. Grab my handy little helper. And with a square, you square your depth of cut to your line that you would have done before. And then it's going to be first level cut, so you're going to chisel into that knife wall, give yourself a groove for your saw to bite into on both sides. Then you're going to go to your crosscut saw and saw this square down until your piece comes off. And paying attention not to overcut, because it will be seamed. And you just do that for the other side, and then we'll clean it out with a chisel. And there you have your frame to your framed and panel desk door. Now we have to cut our panel to size and then thickness it to fit within our grooves. A quick note, if you are following along in Hamler's book, he doesn't give you the finished dimensions of this frame. He gives you the thickness, which I think these are like 2.5 inches, but you're going to need to custom size the height and the width of these rails and stiles to fit your actual hardtack box, and I think that's good practice. The other thing too is keep in mind when you're making this to make it a little short based on if you're going to have a formal top to this desk or not. If you're going to have a formal top instead of just the top, the side of the hardtack box, you'll want to make sure this is just a little bit short. So if this expands, that your door won't swell to the lid of the desk and you won't be able to open the door. So keep that in mind. The other thing is you can do the panel a lot of different ways. Hamler just thicknesses a lid essentially down to 1/4 of an inch. You can also make a raised panel where you would probably just use your standard 3/4 inch, and then you essentially cut these angles on all 4 sides with a hand plane until the edges get to your desired thickness, and you have a raised panel. And doing that with a hand plane actually goes pretty fast. Or you could even cut a shoulder all the way around on all 4 sides. It's a little more work and a little more finicky, but there's all sorts of different ways to go about making this frame and panel door. I went ahead and mounted the hinges onto the mounting strip of our door. So that way the door can hinge down like that. And you want to get a nice, even, tight seam along the bottom. Now, since I've already installed these, I'm going to show you how easy it is to cut hinge mortises by hand and a few things to factor in during your layout. Cutting a hinge mortise by hand is fairly simple. You only need a few tools and it goes pretty quickly. I have my marking knife, my router plane, a sharp chisel, and a mallet. Now, you want to lay out your hinges wherever is going to be convenient and out of the way of any joinery that might make it easier to chop the mortises. Now you need to figure out sort of the depth of your hinge. Now, a lot of times when people think they're going to start to chopping a mortise for a hinge, think they just need to compensate for this depth of the hinge, the thickness of the leaf itself on either side, and they'll be good. But what happens is, unless you buy a fully swaged hinge, you have this gap, and this is going to show up in your piece. So when you cut your mortise, you have to factor in this gap into your cutting. And you want to be able to absorb this distance so that when your pieces are hinged, they sit flat. And typically what I do is I just kind of sneak up on it and test it a few times. It doesn't really waste that much time on my part. There are sort of little formulas and stuff that you can do to figure this out. But keep in mind that if you're going to get a nice flush mounting hinge, you're going to have to make sure that your mortise is going to be a little bit deeper so that when everything is closed and flush, that this sits equally on both sides of the pieces. You can absorb the swage gap on one side or the other. I typically split it between the two. It's up to you. So now that we have that out of the way, all you have to do is place your hinge on wherever you want it. And I try to keep them on the same side. So if I have, like, maybe I want to install the barrel side. So the barrel side, this side, will be the same on that piece. I try not to switch my hinges. So I'll put the barrel side in this example up to the piece where I want it. I'll hold it firmly, and then with my marking knife, with a light first pass, I'll carefully mark and then go a little bit deeper on successive passes. And this is going to give you a knife wall. And take your time, do this accurately. There you go. That's going to be really hard to see. I'll just darken that in a little bit. So now you have a place to work to. Just like any sort of knife wall cut, we clean out a little bit of the waste to protect that shoulder. And then all you do is you just keep your chisel square. And you chop. It's almost like you're cutting an actual mortise. You don't have to tap hard. So now you get all this waste. You can flick it out. And then you can sneak up on the cleanup with your router plane until you get to the final depth. Each time you go around, you clean up your shoulders, find your knife wall, make your chisel perpendicular, and this will give you a nice clean result every time. Now, using the same principles that we use to install our hinges for the door, we're going to just make an even bigger mortise. So with a half mortise lock as the locking mechanism for this door, all you do is the same thing. You just cut a bigger mortise. So you find the center of your board, you eyeball where you want your lock to go, and then once again, you hold it firmly, trace around it with your marking knife, make the lines a little bit deeper each time you pass, and then once you have that, you take a ruler and you measure from the edge of the faceplate to the lock assembly on all three sides, and then you draw that on, and then you cut it in with a chisel, or you can use your marking knife in a square, and you cut out the hollow for the lock assembly. And to find that depth, you can either set your square or your router plane to the depth of the lock assembly. Mark that so you have a starting line on the edge to a baseline, so you know your final depth when you use your router. Now you want to be careful not to cut too deep, because you need to leave enough meat on the wood so you can bruise the wood with this pin for the key. So when you're almost done, you want to put it in there, and it's going to sit a little bit proud, and you give it a tap, a gentle tap with your hammer, or you push it in by hand, and it's going to leave a dent where you need to drill your hole for the key, and then you can drill another smaller hole below it, and then connect the two with a file, or however you want to make that classic keyhole shape where the key is going to go. And then you just keep cutting away until everything sits flush on both sides. Now, I get these half mortise locks from Horton Brasses. They're not a sponsor. They just have excellent products and excellent customer service. And the other nice thing that I like about the products I get from Horton is they send the hardware with slotted screws. And that saves me a trip to the hardware store, because the last thing you want to do putting this much effort into a historical reproduction is to use Phillips screws or other modern screws. So it's nice to get slotted screws the first time, and that way I don't have to stop what I'm doing and make another trip. So once you have this done, then I would glue the door to the desk. And what you're doing is you're just gluing that bottom strip on the bottom of the door that you hinge to, and you just glue that on, let it clamp it up, let it dry. With our half mortise lock installed, now it's time to figure out where to cut the mortise for the bolt of the lock. Now for this lock to work, we need to have a formal top, like in Hamler's plan, and we need to cut a mortise for it. So in order to do that, I have my formal top installed with just clamps. Hamlet's plan has a 5/8 inch overhang on the three sides, and I just find that using a square, and where I find that I like it, I'll trace around the inside of the formal top with a pencil, so that way I can mock it up faster the next time. Now, the other thing too is this is a good time to check before you go much further that you can open and close the door freely with the lid clamped down. If for whatever reason you're hanging up, now that we have the lock installed, we really can't shave the door. Plus you have ingrain, which can be a little tricky for new people. But what you can do with your formal top clamped down is you take a pencil and you trace along the top of the hardtack box where it meets the inside of the formal top, and then you remove your top. And in this distance here, you take a smoothing plane and you take some shavings off, essentially sort of making like a very gentle taper. And you don't need a ton of room, but you got to make sure there's going to be space for, you know, this top to maybe bow or cup, depending on your weather conditions, or maybe the door to swell. So you do want to have a little bit of room, but you still want to make sure that you have plenty of room for your lock. So in order to figure out where to cut the mortise for this lock, I'll raise it up, and then I'll use just a Sharpie, and I'll color the top of it. I'll lower the lock, and I'll push the door in where I want it. I'll raise the lock, drop the lock, and now I'm going to have a marker footprint of where to cut my mortise for this lock. The other thing too is I also ordered a striker plate for it, which I misplaced. So this is going to be my chance to make sure I have enough room underneath my formal top for my brass striker plate. You don't have to have one, just a mortise cut in the top of the wood will be more than adequate to provide a good locking surface for many years with this sort of setup. Now, since the Sharpie left a black rectangle on the underside of our formal top, what I did was I took my square and I squared around the edges so I have a nice equal reference surface from the front of the top. And then I just took my 1/4 inch mortising chisel. You could use a regular 1/4 inch bench chisel if that's all you have. And then I just started chopping a mortise until I got to the depth that I wanted. And the depth is the height of the bolt when it's open or when it's locked. So you just measure that and make sure you have enough clearance. Now I'm ready to put in my strike plate. And so just like our hinges and the half mortise lock, you find where you want it and then you trace around it. You cut it in with your marking knife and then you find a chisel that'll fit. In this case, 1/2 inch chisel. And then I'm just going to mortise in the thickness of this brass plate so it sits nice and flush. Once you have mortised all your components for your lock assemblies, you're ready to add a healthy amount of your favorite wood glue to the top of the hardtack box and clamp your formal top to your desk. Once this dries, you're pretty much done and ready to put it into service. Thanks for watching this rather long and involved video, but this is a pretty involved build. One of the more intense Civil War woodworking projects out there. If you want the exact dimensions of everything you see here, be sure to check out A.J. Hamler's Civil War woodworking book to build one pretty much just like this. Keep in mind though, you can adapt this however you want in any style that you want. It's going to fit your needs in the hobby. For finishes, you have some of your standards. You have your boiled linseed oil and shellac if you want a little bit more of a built-up film finish. Shellac is not super durable, but it will add more water protection to your desk than just straight boiled linseed oil. Or what most likely happened is that the soldiers just left it plain wood. And shellac you can reapply and refurbish as needed with minimal preparation, so that's very handy. For this piece I used a tung oil finish. The coloring mimics period correct finishes with a little bit more modern chemicals in it to add a little bit more protection to the wood, even though tung oil didn't start becoming a thing in the United States until about 1900. Since it's been hot here, I cut my oil finish with a little bit of mineral spirits to give me a little longer open time for working with it. I would stay away from I would probably just stay away from any modern film finishes, especially if this is going to be used regularly in reenacting for you. Varathanes, polys, and lacquers can get brittle with age and they can crack, and it's going to look unsightly, and all finishes are going to degrade from UV light. But when you have like those film finishes and they break or they degrade from the UV, moisture is going to get trapped between the wood and the finish, and that's when the board starts to gray and you might start getting mildew, like old patio furniture or deck boards. And that's why I like to stick with oil finishes, because you can just reapply as necessary, and they oxidize and polymerize naturally, and it's period correct. So I'd keep that in mind. I'm going to be a little bit controversial, and I'm going to say try not to stain your piece. I personally think that stain can make nice pieces like this look pretty cheap. Stains, faux finishes existed during the Civil War, but you have to keep in mind, if someone in the 1860s wanted a brown piece of furniture, they used walnut. If they wanted greens and purples, they'd use a tulip poplar. If they wanted something kind of in between, they'd choose like a cherry that darkens over its age. So I would kind of stay away from stains. It looks a little hokey, and remember, this would have looked new, so you don't make it look old-timey. And then the other thing too, and I talked about this in my old Civil War Woodworking Secrets Revealed video, paint in the hobby is really underrepresented. You could paint this. Latex paints would have been period correct, and the other thing you could do is maybe like a nice milk paint, and milk paint is widely available these days, and it's fun to mix up, and it gives you a really unique finish for a unique piece of Civil War furniture. Hardware is kind of up to you. Be creative, just keep it period correct, and let the piece kind of guide your narrative as to why it looks the way it does and why you built it the way that you did. So thanks again for being part of this wonderful community. We couldn't do this without you. Let me know if you have any questions down below. Thanks as always for liking and subscribing. And to stay updated on all of our future videos, be sure to click that notification bell. And we'll see you next time.